G'day. This video goes out to Jake to some degree because he is bringing up some of the things which I absolutely love. And he's been going on the SunCalc app, and he was talking to all his followers about the fact that on the day of Equinox, which is the 22nd of September, that all of the sunset and sunrise positions is all exactly due east or exactly due west. The angles might be 1 or 2 degrees out of whack, but I mean in general they're all dead in line, and he's bang on right. And I wanted to show him what I also see, because I see that same thing as well. But also wanted to illuminate him to a bit of a thought, which maybe he already sees it, but I didn't see him mention it, so I thought I would mention it too. So I've done this before on the SunCalc app as well, and during Equinox 22nd of September, it sets due west. Sometimes it's a little bit off. Like this one here, where is a sunset? Well, it's got a time. It doesn't say where the sunset is, but anyway, and the sunrise is due east. And if you move the cursor, down to the equinox, it's dead straight. And if you go down to a Ushuaia, which he pronounced 100% correct, it's pretty, unless us speaking English, maybe we don't know how to speak Spanish, but and as you can see, the sunset's a little bit below due west, and sunrise is a little bit below due east. So the one thing that I did want to bring his attention to, which I'm sure that he probably already knows, but I just wanted to double check, was, as you can see, how this yellow line bounces over the top. All right, so that's the sun path during the day. That will be obviously as far as south as possible. The sun bends as far up as possible, and as you would come closer to the equinox, the sun is traveling straight over the top, which he was alluding to, but he wasn't necessarily alluding to the other things. And as you can see here, if I bring it up to New York, the yellow line bounds down, right? And so basically, what that basically means is obviously that in the northern hemisphere, the sun passes to the south side in the middle of the equator. It passes directly overhead, and in the south, it passes over the north band, right? Now, I like this particular website, Andrew Marsh. I believe he's actually an Aussie, so I found that the other day, and that's bloody awesome, because trust Aussies to go out there and bring out some good stuff. And there's a few things on here. So we've got the sun path map. This is very, very similar. As you can see here, it's got 2 orange bands, one being, probably like the winter and the summer season, based on which hemisphere you're in. And as you can see, all you just need to do is just bring this cursor, and it's actually quite adaptive. It's, as you can see, it's rolling with me. So if you bring it straight to the equator, bring it down to Ecuador, you'll see that straight line straight through the middle. And if you pan it up, as you can see, the band is bending down, and that's really, really good as well. It shows that the sun is panning to the southern end. Now, if we bring it down to Ushuaia, you'll notice that it bands over the top. Now, one thing I just noticed on some calculator before is if you try to go too low, it stops. It's sort of landlocked, and it doesn't really go too far south, and I can't get above Norway. So this particular website does seem to be a little bit landlocked when it comes to getting its data. I can't go as high as Svalbard or on middle of Greenland at all. But on this particular website, I can. So I can go. I can bring this cursor all the way down to Antarctica, and as you can see, you'll see the band up here. Now, during equinox, obviously, look at, even in Antarctica, it sets due west and rises due east. It'll band across, but as you can see by this inner ring, you'll have a 24-hour sun in Antarctica. Now, if I move up to North Pole, This is the one thing this particular website just has a little bit more over the SunCalc website. Mind you, the SunCalc website does have a whole bunch of data on here, but this one doesn't necessarily have that data. You might be able to open it up on something else like this. You'd have to look around, but it shows data in different ways. And as you can see about this one can go as north as Svalbard up here. So, and as you can see, we've got that inner orange ring, and that inner orange ring is basically where they're getting the 24-hour sun up in northern Norway, right? Now, he mentioned something about the fact that this red line comes over. Well, not necessarily this red line, but he was alluding to the fact that the angle of where the sun sets and sun rises seems to be above the this east-west line in the north, and when you go down to the south, well, it doesn't necessarily show it here. It looks dead on, but when you go down to the south on this one, you notice how the arrow points down. Now, he said that shows that even if it was on a globe, that it would be the angles are pointing outwards, and that would mean that you couldn't triangulate the sun at all. It would be just going out to infinity, and it's going in the complete opposite direction. That's what it kind of looks like. It looks like, for some strange reason, this line is going down too far, and the one on the upper side is going up too far, which would mean, where the hell is the sun? The sun is far up top or far down below. What is the case? Well, the best way to be able to visualize this sort of stuff is to be able to go to something that's more 3D. So as you can see up here, this is the same Andrew Marsh website with SunCalc, but you can actually place it on the globe. And one of the good things about when it's on the horizon, it has to look back on itself, which basically means that position can quite happily look back on itself and be dead in line. So see how that sunset is pointing dead direct straight? Well, if you drag that latitude all up to the North Pole, pretty much, what it has to do, it has to see the sun in the background. And so it's going to bend back towards the center. So it will overlap the west line just that little bit to align itself with where the sun is. So that would be what I would try to let people visualize from a 3D perspective, is that while the equator has a dead straight line on this particular map here, when you go up into the northern area, it's on the top of the globe, and so it's wrapping itself back behind it, sort of over its shoulder, as it peers towards the sun off in the distance. There's a better view. So if you can imagine that the sun is setting, if the sun was directly in line with this white line, you see how that is there? If you're somewhere up in the top there, your angle is looking back this way. It's not looking straight along this way. It's looking back to the sun over its shoulder. So that would be the answer as to why it has to bend up. And same sort of thing if you were to roll down onto the south hemisphere down here, right? So if you're down the south hemisphere and you place the sun directly in line with this this south point line, this sunset angle has to point back towards the sun. So that's why it is hyperextended on the western line, because it has to point back towards the sun. Now, one thing I thought I would do just to cap this particular video is to show why it is that on this particular globe that everything seems to point dead on 90 degrees west when it's sunset. And if you can just watch the blue line, as you will see, the blue line's always, roughly straight as it's doing its thing. That wouldn't make sense on a flat Earth scenario, because you need to triangulate to the sun from all these different points to be able to get to some point which is supposed to be 3,000 miles, which is less than the radius of what the planet actually is. So all the lines would all be intersecting in a weird way. But in this particular instance, as you can see, you just slide up and down and everything is 90 degrees because you're running the edge of the ball. I'll just show it for the morning just to show you the same sort of thing. It's the same sort of scenario when you get to this point. So as you can see, the blue line looks like it was... Let's zoom in on that. As you can see, there it is. See at that point there? So at that point there, that's when the sun is right on the cusp. And once the blue line is exposed, we're good. We've got the morning sunrise right there. Now, if I pan back out again, and if I look at the time of day, if I look at the latitude, as you can see, it's like it's peeling the orange, right? So that it's just scraping down left and right. And as you can see, that blue line is pretty much 90 degrees to the west, like to the east every single time. Sorry, I said that all wrong there. So it's pointing due east at 90 degrees from top to bottom. All right? So that explains why such things, why the east here is continuous. See how it's sliding up and down? And the east over here, it's tied. It's like it's locked on the east. And if you look at the west point over here, it's locked. It always sets exactly west, and it always always rises exactly east. So I hope that allows people to understand the way that works and how fantastic the Equinox is, because for pretty much every single part of the planet, everybody's got 12 hours day and 12 hours night. Equinox is awesome, and it's fantastic globe proof that it cannot be proved on a flat Earth, because if you're on a flat Earth, the outer part of the disk has the same amount of hours and the inner part of the disk has the same amount of hours. How does that work? Because one piece of light might go 200 meters, and another piece of light goes like 5,000 kilometers. So how can one that goes 200 kilometers and one that goes 5,000 kilometers be the same? It's not possible. That doesn't make sense. So that wraps up my greater summary on how Equinox is perfect 90 degrees east and perfect 270 degrees west. It's a beautiful thing. Thanks.